Welcome to Skillgain Academy. The last time we have detailed discussion on principal component analysis. There we have covered the theoretical aspect, when the PCA should be done, what are the advantages and disadvantages of principal component analysis. Today we will have some different approach. We see a hands-on how we reach the principal components from a big data set and how the dimensionalities are reduced. Let us see it with an hands-on example. So at first we have import all the required libraries from Python like NumPy, Pandas, all those things. I am not getting in details in the codes. Just see step by step how we reach the final principal components. So we have taken a data set on pumpkin seeds. There are different measures: area, parameter, major axis length, minor axis length, convex area, like that you can see it. And after that, the class of those pumpkin seeds. So first, let us see the details of the dataset, the basic details. The shape, so it is 2500 rows and 13 columns. Total 32,500 entries. With the info command, we can see there is non-null values of 2500 each, and there are 2500 rows. So there is no question of null values, and everything is integer or float, numerical, except that class, which is an object, because those are categorical values we have seen. Though we see that there is no null values, but still we are checking with the is null command, and all are coming zeros. So no null values, and all variables are numeric except class. So for principal component analysis, we have seen that in our earlier video that there should not be any categorical variable. Principal component analysis can be applied only on numerical values. So we remove the column class with permanent removal. After that deletion of the column, now it is a 2500 row and 12 columns, and size is reduced to 30,000. The next step is to check the duplicate rows. So there is no duplicate rows. It is 0. Then we see the 7-point description for all the numerical features: counts, what is the mean value, what is the standard deviation, minimum, maximum, and the 3 quartiles. So this 50% quartiles is nothing but the median. If you see, for all the variables, mean is very near to median, 50% quartile. That means basically they are very near to normal distribution, and that is the first assumption made by principal component analysis. So our data set is to some extent is good fit for a principal component analysis. So let us plot the box plot to see the outliers. For principal component analysis, outliers should be removed. That is another assumption. So if we put all the box plot together, these two, area and convex area, having very larger values. So this graph is not that much visually perfect because we cannot see the other features. So we divided the features into 3 separate groups according to their values. So 2 high values are taken together and we plot separate box plot for area and convex area, and see there are so many outliers. These are outliers in the higher values. The next set is this. Here is also outliers. Another set is this for small values. Here is also outliers. See, for the small values, outliers is mostly concentrated on the lower sides. So a lot of outliers are present in each variables. Now let us take the percentage wise outlier present as a whole of the data set and in column wise, in particular column, how much percentage is outliers. So we have done this outlier statement. These are the standard coding for outlier statement. Q1, Q3, first quartile, third quartile, then IQR, interquartile range. And we fix up the upper limit and lower limit with the formulas Q3 plus 1.5 IQR and Q1 minus 1.5 IQR. Then we find the number of observations in each column according to the descending numbers. And total number of outliers is sum of them. So if we formulate those things, it comes that percentage of outliers in total it is 1%. And column wise this solidity having 4.12% outliers, extent is 1.84 times percentage outliers like this. So in total 1% outliers present in 12 features all together in the data set. And maximum outliers present 4.12% is solidity, followed by 1.84% in extent and 1.20% in minor axis length. So what we do now, the standard outlier treatment is to cap those outliers in the maximum and minimum limit, upper limit and lower limit. So that we have done by this command df of I each column np dot where we have find out where dfi less than lower limit, replaced it by lower limit, otherwise as it is. So the same thing is done for the values more than upper limit also. If it is so, replace the upper limit, otherwise keep the value as it is. If we put this and check the total number of observation which is outliers, now it becomes 0. So what outliers have been kept.